Okay, so we have Carol. We have Carol. She wants to move the 32-kilogram sofa to a different room in the house. She places sofa sliders, the pre-disc, with the coefficient of friction, the kinetic coefficient of friction of 0.08 on the carpet, um, under the feet of the sofa. She then pushes the sofa at a steady 0.4 meters per second across the floor. How much force does she apply to the sofa? First, I'm going to highlight this part of the sentence or this question. What is something special about this? Yes, it gives you the velocity, but something more than just the velocity. Can you read into the line of what is going on here? Steady part. Constant velocity. So, there are a lot of ways to tell you that it's in constant velocity. And whenever you see, you feel, you recognize that it's a situation where velocity is constant, that means what? Because the acceleration is 0. Okay. All right. So therefore, that's a very important premise that we need to know so that we can understand what is going to be the situation scenario. And now we say that, all right. We are going to push the sofa. And so let's just say we're going to push it to this direction. So we're trying to find the applied force. And apparently, we have to draw the 3-by diagram. So I'm going to let you draw the 3-by diagram of this sofa. How many forces should there be on the sofa? How many total forces? Four. So we have one already. So our usual suspect, force due to gravity. Since it's resting on the floor, we have our normal force. And then since we are going to have some sort of friction to keep the object, to keep the sofa moving at a constant speed, so we're going to have the kinetic friction. All right, so I'm going to ask the same question that I asked earlier from question 1. What is something that you can just go ahead and calculate or tell almost right away? What force can we find out right away? Force of gravity, okay, because the object, it's 32 kilograms, right? So we can go ahead and find out force due to gravity. That is just on a flat surface. So no need to worry about any trig function. So 32 kilograms, 32 kilograms times negative 9.8. So you have a negative 313.6 newtons. Okay. So, or you may round it to 314. Okay. Or technically, if you use significant figures, it would be 310, but let's just go with this for now. All right, so we've got ourselves the force due to gravity. Do we know other force here? Any other force that we know? That's pretty obvious. The friction? Well, the friction is going to be the same as the applied force, but we don't know what the friction is yet. We could calculate it. That's going to take us some more steps, but is there anything that's easy to find out? Normal force. We are just having the object on the floor, and the force applied is not vertical, so we can actually tell the normal force right away because it is simply positive 313.6 newtons. So in this case, it will be the opposite of the force due to gravity. the weight of the object. Okay, so we know two things already. And now, one thing that I really want you to realize is that you should be aware of the formula that we were talking about from question number one, which is the frictional force. It's equal to mu times the normal force. We've got the mu, we've got the normal. That means we can tell the friction. Okay. So again, it's more about a mentality, a lifestyle change. We are not going to prompt you every single step. You need to initiate all these work and say, oh, I can actually find out the friction because I've got my mu k and I have just got my normal force. My mu k is 0.080 and right 0.80 and then my normal force is 313.6 newtons. And since it's going to the opposite direction of the motion, so we're going to tag a negative on the force. So we'll go ahead and calculate it. And we should get 25.1 newtons, okay, with the negative. So therefore, the force applied to keep the sofa moving forward would be 25.1 newtons. Okay. So now, what I really want you to see, what I really want you to see on this question is that if you look back to this question, okay, from the beginning, would you be able to formulate these little steps without knowing the numbers at the moment? Okay, would you be able to say, okay, all right, I can draw a free body diagram. I would be able to tell the gravitational force. I would be able to tell the normal force because they are the same, but in the opposite sign. And because I have the normal force and I have the coefficient of friction, I shall be able to get the friction force. And that would be the value of my applied force. You've got to have this plan, okay, in order to start the problem. If you don't have the plan, well, it's just challenging, okay?